Feeding an increasingly hungry world and providing it with renewable energy sources will take more than just acres and acres of farmland. It's going to take research, like the research that is being conducted at our nation's land-grant universities. At these institutes of higher learning, scientists are researching everything from a food safety cancer cell connection to cellulosic ethanol production. This research is conducted both on the farm and in the lab. On the campus of North Carolina A&T State University in Greensboro, scientists in the Food Microbiology and Toxicology Lab are working on extending the shelf life of fresh produce.
So far, with the bacteriophage technology, we were able to extend the shelf life of many fresh produce, mainly leafy greens like lettuce, spinach types, 2 more weeks.
And one method of using plant oils to extend the shelf life of produce is also beneficial in the fight against cancer.
We also do research on cancer cells. We are trying to come up with some new preventive techniques, completely natural, again, plant-based products, and currently testing on colon cancers and breast cancer cells.
For land-grant universities, research must also extend from the lab to the farm. At North Carolina A&T's working farm, the focus is on assisting producers with small farms produce more on less acreage. But there are broader projects as well, including biofuels.
And most of our research involves utilizing the agricultural waste to produce bioenergy and biofuel. An example of those agricultural waste is swine manure that we have from this swine house that we have 125 hogs in the confined space. All the waste is being flushed out and then put in one of the lagoons, and then most of the solids settle.
The experiment involves cattails that are grown in lagoon waste.
So the cattails have 2 components, the leaves and stalks, mostly lignocellulosic material. We can utilize that and then pre-treat it, separate the cellulose and hydrolyze the cellulose in order to produce simple sugar, which is glucose, and then from glucose we can ferment it to produce ethanol. But also we take the solid waste, solids from the swine waste, and through that hydrothermal pyrolysis we produce bio-oil, oil that comes from biomaterial, in this case animal waste. So that is another integral part of this extracting energy from agricultural waste.
As always, research of any kind cannot be rushed.
We have done most of the laboratory work. We have one additional project that's underway. We are just getting started, and that is the bio-oil that we produce from here. We are going to upgrade that to produce a gasoline substitute to be used as transportation fuel. And we have been able to do all of the necessary research in the laboratory. The next stage will be doing some kind of a scaling up, trying to determine how this work that we have done in 1 liter flasks in the laboratory can be done in 1,000 gallon and 10,000 gallon in the commercial state. So that work has to be done later on, and I really don't know who might pay for that part of the work, because government doesn't pay for those kinds of research.
And that can be the big question. How much funding is needed and where is it going to come from?
And then I guess venture funds or industry has to pay for the scaling up of this process.
So as research projects at the school progress, the industry that will use the research has to get involved.
Using the animal waste is a very excellent feedstock for producing ethanol. However, nobody will buy my word, and then we have to academically and technically show that feasibility.
Much of what we eat, wear, and in the near future put into our gas tank has or will come from research conducted by land-grant universities such as North Carolina A&T State University in Greensboro. So the next time you open a package of romaine lettuce or fill up at the gas station, think about the science behind the product and how it's making our lives just a little bit better.